Hello and welcome to part B of the General Electric X225A Death Radio. And what a long, strange trip it's been. I spent about a day and a half going through this and changing every single wire in here with the exception of the cloth covered stuff, which is still in pretty good shape. Everything else was just rotten to the core. And I actually pulled out the IF transformers and replaced all of those wires as well. But that was strange. The first IF transformer, normally you have red B+, blue anode, green for the grid, and yellow is what they'd labeled for the AVC line. These had faded to white. I'm assuming they faded to white. The second transformer was so faded that I could only make out the red until I got it apart, but as long as I knew where the red B+ was, I was all set, and that agreed. This was going to the B+. When I got inside where there was still some color left, the blue wire was actually a brown wire. And over here, the white wire, which was actually supposed to be yellow according to this, went through the hair, and instead of being green, it was blue. Now, these manufacturers tended to put whatever color they wanted. They didn't always follow the convention, because normally I think the AVC was brown. At any rate, I made them all match this schematic. So I made them with the red, blue, and the yellow, green, red, blue, yellow, green. So the two IF transformers are wired up with the colors that are on the schematic. So that's been taken care of. I have not put a power cord on it yet. I have, however, found relays that will work for isolating it from ground in its entirety when we've got the radio up and running again. Make sure I'm in frame here. Yes, we are. This is remember in part A I said that I had ordered two relays that were 110 volts. And they came in, this is just one of them. They came in with a piece of DIN rail, which was kind of nice. So you could mount this on a DIN rail if you wanted to. It just snaps on the DIN rail. Also, the mount has two holes if you wanted to screw it down inside the cabinet. And it makes wiring simple because it's 110 volt or 115 volt winding. So you don't have to worry about doing anything with it. Plus they unplug. And it has very large lugs or terminals or pins or whatever you want to call them, which would make this a piece of cake to solder. And that's what I'm going to do because I've got a hole right here that it fits in, and it ends up being flush with the bottom of the chassis. So when the radio's up and running, we'll wire it up so that when you turn the switch on, it activates the relay. The relay will close both legs and attach the neutral and the hot, and when the radio goes off, the relay will drop out. So that's taken care of. Another option would have been this 24 volt relay, which nestles right down in there, or I even have a double pole 12 volt relay. And I was going to use a capacitive dropper until the 120 volt relay showed up. But if you were interested in doing the capacitive dropper route, if I can figure out what I did, oh, maybe it's over there. Okay, all I had to do is look one page deeper on the clipboard here. I'm going to be wiring up the 110 volt relay just like it's shown here. Now this is not an existing switch. That's just in case it was high side switched. You just move the switch to this position. Doesn't matter. Activates the coil, and your line and your neutral will get connected. Neutral, of course, going to the chassis ground, and the line going to the tubes and the rest of the circuitry. If you have a relay that's drawing 30 milliamperes, and both this 24 volt and this 12 volt unit do, it's a super simple circuit. In fact, you could leave out the 1 mega ohm resistor if you wanted to. Same thing, this is just a phantom switch. If, you know, the switch was on the line side, this would be a straight line through. 560 nanofarad or 0.56 microfarad capacitor. Passes enough current, passes about 23 milliamperes, which is more than enough to pull in these 30 milliamp relays. They just click right in solidly. Little bridge rectifier, little back EMF diode so that when the thing shuts down it doesn't beat the bridge up. And same wiring, neutral side, line side. If you have a relay with a different current draw, then you can go online. They have capacitive reactance calculators, and just come up with how much current you need, figure out how much of a resistor you need to drop it down to that current, or how many ohms you need, and then do the calculation to figure out your capacitor. But a lot of these relays draw in the order of 30 milliamperes, and 560 nanofarads works out perfect for that. But we're going to be going this route because it's just less component count. Little bridge rectifier like that, and the capacitor, you could just about mount them on the relay. We're going to go the easiest, simplest route. I believe in the KISS method. Keep it simple, stupid. Okay, let's get ready to do some testing on this radio because it's been 100% rewired. I worked carefully, but I want to make sure I didn't make any mistakes. As we were getting started, the mailman showed up. One of the 3 orders I placed with DigiKey showed up. These are the 500 milliampere continuous current. Now these are only 33 ohms cold, but they do drop to 1.45 ohms hot. The 2 others that I ordered that they said they had in stock ready for immediate delivery are still scheduled for sometime in 2022 if they decide that they're going to actually ship them at all. So when we get done with the radio, we'll measure how much current this one draws. I know I think it was the Triad was drawing 400 milliamperes, which would be a good test for these. But we'll plug them in one of the radios and see if we have anything to gain by using these. We'll see if I'm all wet or maybe I got lucky. No power cord on this yet. I think I said that. I'm going to take a resistance reading on the filament string. Now this is going to have the transformer in the circuit, so what I'll be looking for is when I pull the 12SA7, we'll see if there's a change in resistance, so I know the filament string at least is intact, or you know, there's should be some change in resistance at any rate. And we'll stick that on there. There's the other test lead underneath here probably. Oh, already connected to the chassis, which is where the switch goes. I'll put it up here on the switch. And I'm not seeing anything. That is the connection for the line cord. Oh, gotta put this on AC ohms. There we go. So, is that meter in? Yeah. We have continuity through the switch. Now, oh, I think we got a flaky switch. Probably need to give that thing a shot of deoxit. Is there a hole somewhere? I don't see one. Maybe I can squirt some down through here. Let's see what happens. I don't know if any of that got in there or not. Doesn't appear. Whoop, maybe it did. Nope. We'll worry about that later. It's connected right now. Let's see if there's any change when I pull out the last tube in the string. And yes, there is. There's a change in resistance. So, it looks like the filament string's wired okay. I know it's not much of a change, but that's a very low ohm reading on the, we're only 40 ohms on the transformer, so it's not going to be much of a change. We'll go on DC volts, 150, and I'm going to hook up my DC source here that I usually use for checking the filter caps. We know they're in good shape. We'll connect this to ground. There's a good ground. And here's my first filter cap. We're going to inject the voltage here into ground. So we'll be checking through the resistor, through both caps. Then I'll check for voltage on this anode. Now there won't be any voltage drops because the tubes aren't active, but I should have voltage on all of my anodes if I've wired everything up correctly. And we shouldn't have anything on any grids. So, DC source on. This is off. Connect this. Come on, get on here. There we go. All right, I'm going to turn this on. The frame, yep. All right, we're not drawing any current we shouldn't be drawing. It looks like the caps are in circuit because it blinks on both charge and discharge. So up here on my 50L6, my anode is pin 3. 1, 2, 3. Why am I not seeing voltage there? I'm on DC. I should have close to 100 volts there. My test circuit's in. Why am I? Oh, there's something wrong with it. Gotta be something wrong. Oh, ho, 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 ho. Did I knock the ground lead off? Yes, I did. I knocked the ground lead off. Scared me for a minute. Okay, back here we have roughly 100 volts DC there, so pin 1, 2, 3. Roughly 100 volts there. So that means we're good up through the primary of the transformer to the anode of that tube. And then pins 6 on the 12SQ7. 12SQ7 is A7, so that's this one up here should be pin, what did I say, 6? Yes. I can never see the doggone. Okay, 1, 2, 3, 4, 5, 6. Yes, we have 100 volts on the 12SQ7. The 12SK7 will be this one, and that's going to be pin 8. So the keyway is there. This is pin 8. 100 volts there. And pin 3 on the SA7. Oh, there goes my clip lead again. 1, 2, 3. Okay, we've got 100 volts there. So it looks like I've got the anodes all wired in. We're not drawing any current, so nothing's shorted. comfortable enough. My DC is going to the right places. I'm going to go ahead, put a cord on this, and we'll bring it up on the Variac. Give me a minute. Okay, moment of truth. We have never had this set playing before. It's never been powered up here. So we don't know if it worked or not. And I have shotgunned everything, plus completely rewired it. Literally built the set all over again. A little blob of solder there stuck in the plastic on the cap. Oh well. So we're on dim bulb. Variac's on. Radio switch is on. Let's start bringing up the power and see what we get. We make sure I'm recording. Yeah, we are. Alright, I've got pilot light action at 20 volts. 30 volts. We're starting to see some activity on the little auxiliary voltmeter down here. Is that in? Yeah, that's in frame. And I've got my VTVM hooked up on the B+. Drawn not even 100 milliamps yet. Okay, there's 100 milliamps, 110. I would expect to start seeing some B+ by 40 or 50 volts here. I would hope. There we go, B+ is coming up. Volume all the way up. There's 65 volts up there, 66. Still not under 200 milliamperes. I'm touching where the first audio amp is fed. Surprised I'm not hearing anything yet. There's 80 volts. Oh yeah, starting to get some activity out of the amplifier. So we have an audio amp. We're 120 up there, the dim bulb's glowing a little bit. We're starting to get some audio amp action.
I can find you in whatever circumstances you're in.
Well, what do you know? It's alive. Phew! Oh. I don't know what band I'm on. But I'm going to guess that's AM. I'm going to guess that's shortwave.
This is a powerful message because what he's...
I'm going to go, we're 120 up there, I'm going to go full bore.
going to use your family to bring my good news, the gospel, to the nations. That is to the Gentiles, you and me.
Well, that woke it up. Let's try this.
60 grand in the bank. Well, on the iHop.
Yeah, this is the AM band. The other one was the shortwave band, so both bands are working. That's good.
It's Across America Radio. Radio, now available on the iHeartRadio app, has a live morning show every weekday morning from 6 until 10 a.m. Eastern, along with a variety of special programs that support the mission to remember, honor, and teach. Check out Reads Across America Radio, now available on the iHeartRadio app. For more information about contests on the station, go to WGRAM.com and click on the contest tab.
And I neglected to mention something that just popped in my head staring at the schematic here. I neglected the other day when I was explaining the audio output transformer, and one of the viewers reminded me I was giving ratios of 10 to 100 or 10, yeah, I think it was 10 to 100 turns, just trying to make it simple to understand. But in reality, I should have said, and I was trying to keep it simple, that when you increase the number of turns, the impedance goes up by the square of the turns. Blech. In other words, going from 2 turns to 4 turns doesn't double the impedance. It quadruples it. So keep that in mind. It's not important for understanding the ratio between the two, but I should have mentioned that the other day, and one of the viewers reminded me of that. Thank you. I think it was Larry and something. Larry, gosh, I forget now. Just popped into my head. I should have had that written down. But the impedance goes up by the square of the turns.
In such absurd fashion that people like me, and I mean, Clay and I weren't on the same show together then, but this is a few years back.
Again, I put that down to my 286 processor. Okay, this thing's working. Now that I know it's working, I think I'll drop the relay in here, and once I have the relay installed, I'll come back and we'll do a quick alignment on this set. But
things I know. I'm praying for his quick.
It's sounding pretty good. We do have an external antenna on it because this set, does not have a loop antenna on the back of it. Alright, I'm going to install the safety relay. I'm going to call that, and we'll be back. Actually, no, I'm not going to move on and do that because I haven't checked voltages yet. I did the DC checks earlier, but when I powered it up just now, I wasn't thinking about the fact that this has this auto transformer, and this doesn't run 120 volts on the B plus line. This runs 200 volts, and I should have 190 volts. So this is running a much higher voltage than your standard series string All-American 5 because of the auto transformer. So if the transformer is any good, we should have at least 200 volts or something very close to it. So I'm on the 500 volt range. And that's 150, 60, 70, 80, 185. So it's a little low. And what does it say? At 125 volts. So let's bring it up to 125 indicated. Yeah, there's 120. Yep, there's 125. Alright, we're right on 200 volts. Right on 200 volts. Very good. The 50L6 on pin 3 should have about 190. So, pin 3. There's so much stuff in here. Okay, it's not up here, so it's got to be down there. 1, 2, 3. Okay. Let's see what we got here. And it's 180 volts. I'll take that on the transformer, that's fine. Should have 100 volts on the B plus after the resistor, so that's down here. And we're looking at 100. 1, 2, 3. Yeah, 103. Put it on the next scale up. 150 volt scale. 100 and not loading as much as it should. Might have a soft tube. Our voltage is high here, so these tubes might not be pulling the power they should. Could be the sign of a weak tube, or it just could be the resistor is a little low in value.
For the mass murder, hate crime /
But the important one was this 200 volts here. And I'm glad to see we have that at 125, so maybe the transformer in this is going to be just fine. That would be nice. It's been on for a while and it's not coming up in temperature. This side's warm because of the 35Z5 and the 50L6 right there. These are both throwing a ton of heat. But this side's just as cool as can be, as is the core. So, I am going to put my relay in now that I'm happy with that. I'll be back. Okay, we're back one more time. We haven't put the safety relay in yet. When I started working on the set, somebody had penciled in all the tube numbers, and I hadn't paid a whole lot of attention to it. And then it just dawned on me as I'm looking in here that the set didn't seem to be performing very well in shortwave. It seemed deaf as a stump. There's a 12SR7 in there. It's supposed to be a 12SQ7 according to the schematic. And this is where having more than one tube manual comes in handy, because I can look up. A lot of times the characteristics won't be under the 12SR7, they'll be under the 6SR7, and this manual has everything listed out for it here. The amplification factor of a 6SR7 is 16. The amplification factor of the Q7 is 100. Wrong page here. Amplification factor of 100. Not to mention the capacitances. I should probably tip this down. The capacitance, inter-electrode capacitances are half of what they are on the R7. So they're not substitutable. They are pin for pin identical as to function of what the pins do, but they're not the same. And I've got to go down now and find a 12SQ7. In fact, didn't I bring one up here just the other day? I might have one here in the drawer. That looks like a 12SQ7, so we can put that in. But while I was fishing around, I found this. This is a 6SQ7. It's branded ICO. And it looks for all the world like it's brand new and it's never been plugged in. I've got so many vacuum tubes in so many boxes downstairs that I've accumulated over the year, and I just picked this up because it looked brand new, and I spotted the ICO on there. So that's kind of fun. I'll have to hang on to that in case I come across a piece of ICO test equipment that uses a 6SQ7. Alright, I am going to substitute that tube in and we'll see how it works. Alrighty, we have our safety relay installed, and I installed the NTC, the one that showed up, which is a 500 milliampere unit. The radio is drawing, right now it's pulling 360 milliamps, so we're almost at 400 milliamps. It's close to 3/4 of its rated current. It's 33 ohms when it's cold, and if it was full hot it'd be 1.45 ohms, but even at only 360 milliamperes it's dropping 1.5 volts. I think that's an acceptable voltage drop. It's not bad at all. I'm sure the guys that are putting the fixed resistors in are seeing a bigger voltage drop than that. If they've got a 30 ohm resistor in there, say to get rid of the surge, and it's there if it's 30 all the time. I don't know what most of them are using. I suppose everybody has their own idea on what's right. Now it does get warm. You can't keep your finger on it for too long, but it's not blisteringly hot. So it's perfectly fine right where it is. Now that I know that works, well, I'll wait till the other ones come in. This one seems okay. If the other ones come in a reasonable time, I'll try them out in the same radio and see if the voltage drop improves. And at that point, I'll put some Teflon tubing over the leads and clean it up and make it a permanent thing. But the relay's in, wired into the set. When I shut it off, the relay drops out. Everything's absolutely cold now with the exception of the switch. When you turn it on, the set comes on. I've got neutral wired to the chassis, and the hot side goes to the filament string. So I think all there is left to do on this is go through the alignment, and we can put this radio to bed.
As of now, we don't know. We know there's a new migrant here.
God, this thing picks up a lot of noise with the long wire antenna. Alrighty, I'm going to clean off the bench here a little bit and we'll do an alright. I've been continuing to play with this. You remember I said early on that the E plus at this point here where it says 100 volts DC was high, and I suspected there might be a weak tube. And we in frame here. Try this again. The voltage was high here, and I suspected we might have a weak tube. Turns out all three of them, well, we had the wrong tube here to begin with. The 12SK7 and the 12SA7 converter. So the converter and our IF tube were reading way below the questionable mark. They were real weak. Set was still playing, of course, and that just shows you how resilient these sets are. But when these aren't pulling power, you don't get the voltage drop across this resistor, because we got 200 volts here, we want 100 volts here. So now that I've changed those tubes out, you can see the meter over there. We're on the 150 volt scale, and we're dead on 100 volts at this point. But there's something else I want to point out. When you're checking for that voltage drop, you want to be off a station. You don't want any signal. The reason being, when you're on a signal, your AVC line is going to go negative. It's going to go quite a ways negative, and the conduction of these tubes is going to go way down, and you're going to have a voltage increase right here. But when you're off the station, your AVC line is going to go less negative. Excuse me, it's here. Your AVC line is going to go less negative, more towards the positive, and these two tubes are going to turn on and start conducting real heavily. And when these are conducting heavily, then you'll get an accurate voltage here. If you watch, when I tune, there's the 100 volts, and I'll tune onto a station, a strong signal, and it just went up 10 volts. That's because the AVC is telling the tubes to back off and stop conducting so much, because they don't have to amplify as hard. And if we go back off the station where there's no signal to produce an AVC, there's just some background noise, we go exactly down to the 100 volts that's supposed to be there. So if your readings look a little funky, just remember, tune off any signal that's there.
UNH students, visit their branch inside of Wildcat Stadium, or check out servicecu.org.
That's a 12 volt increase there. That's a pretty strong station.
You can get $50 now.
If I tune off of that station, we're back down to the 100 volts. Okay, I'm gonna finally, I hope, get set up to do an alignment on this set. I've been off eating, answering phone calls. In fact, what time is it now? It's only 7 p.m. I guess I can continue on for a while. We're gonna get set up. Our generator's set up for 455. Now they tell us to start on the grid of this tube and adjust the second IF and then go to the grid and where the antenna comes in on the converter and adjust this IF, but we already have a signal going through, so we can go directly to this grid. You only really need to go here if the set is totally deaf and it's not hearing the 455 kilohertz like the set we did in a previous video where it was so far off frequency, I forget what it was, 55 kilohertz or something, we couldn't hear anything through here. So we had to go to this stage and bring this one in first and then go back up to the front of the radio and bring that one in. But we're hearing reception on this set, so there's no need to do two different connections. I've got my 0.05 microfarad per the instructions, and we're going into the grid on the converter. Well, that didn't gain as much, if anything. Tiny little improvement there. Looks like this thing was pretty close. Go down here to the second. Oh, that was an improvement. Turn the generator down a little bit. Oh, getting way down into the noise. Tiny bit there. This was pretty close. I'm surprised after me rewiring all of the IFs, having them completely torn apart and moving all the wires around. I figured it was going to be off quite a bit, but looks like it didn't have much effect. Okay, that's pretty much peaked up. Now they want us to go to, well, let me disconnect that first of all. Get it out of there so we can set the radio down on its, set it down flat. Come on, let go. Let go. Thank you. I'm going to convert this over to my standard dummy antenna. And this is a little circuit that I got right out of that RCA handbook. A lot of times they'll tell you to use a 400 ohm resistor or a 200 picofarad or a 400 picofarad capacitor or something in series parallel. This was something they came up with in 1938. The circuit that's in here is in that Radiotron handbook. And it combines the two of them to make a fairly flat response curve from the low end of the broadcast band right on up through the shortwave band that these things had. In fact, let me grab the book and I'll show you the schematic if you want to build one. I figure if it was good enough for the radios in 1938, it's good enough for them today. Now, this is what was considered back in the day the standard broadcast band dummy load. And this was what was considered the shortwave dummy load, anything above 2.5 megahertz. And then the IRE in the United States did some experimenting, and they came up with this one right here. And you can see the response curve. On the other page, the AM broadcast had a response curve like so, and the shortwave one had a response curve here. This one has a response curve that's reasonably flat across the whole frequency range. And I'll get right in close and you can pause it if you want to grab those part values. And that's what's inside that little box. So I don't have to keep finding resistors and capacitors, and I just plug this guy in and consider the job done. So, do this without getting bit. And we're still in isolation. Okay. There's still a lot of voltage present under there, and I don't want to get my little fingies in it. Oh, and oop, that was nice. I let this thing cook the whole time I was having dinner and on the phone, and I just let it run and run and run and run. And took some temperature readings on the transformer, which is just as comfortably warm as you'd like. It's just wonderfully cool. And I took some readings on our NTC after it had been on for a few hours. The transformer, when I buried my thermocouple into the tar in between the windings and the frame of the transformer, I used a little Omega with a little thermocouple that I could slide right in next to the windings. I went in for the hottest part of the transformer. The hottest part of the transformer was 45 degrees centigrade, which is about 114 Fahrenheit, which is an absolutely comfortable temperature for the transformer. And the NTC underneath was running just under 60 C, which is around 140 degrees Fahrenheit, which is icy cold for that thing. It's not even struggling, and yet it's still dropped down to, I did the calculation, I didn't write it down. It's dropping 1.5 volts anyway, which I think is an acceptable number. When the rest of them come in, if DigiKey ever gets around to shipping them, if they don't decide they're not going to stock them, we will try the other values that are for 300 milliamperes. But this is running 370, which would push them pretty hard, I would think, but we'll try one. I got 10 of each, so I'm not too concerned. Alright, what the heck was I doing? Oh, we were going to hook up the signal generator through our standard dummy load. And then they want us, come on, get in there. They want us to connect this directly to the antenna, so I'll get this guy out of here. And we'll, clip it right there. And on ground. There we go. And I've got to put my generator on, we start at 18 megahertz. Alright, which scale is 18 on this? I haven't driven this thing in a while. 15, 17, so I need band D. Band D. D is the outside, then we go 18 megahertz. And put this up. Turn this up so I've got enough signal for the signal generator. No, that's not right. That's 1.8. What the heck? I haven't driven this generator, and so okay, there's 17, 18. I want band F2. And we want exactly 9 on the fundamentals, so we have 18 megahertz. So we'll just turn this down. Boom, boom, boom. You got to remember, these generators are all harmonics. You'll almost never get the fundamental on the higher frequencies, because if you look at it on a scope, it's not even a sine wave. It's all kinds of jumbled. It's just harmonics. But we're exactly on 9 megahertz up there, which means we're producing an 18 megahertz harmonic. And post shortwave band, and we want to tune this for 18. Make sure I'm grabbing the right stuff here. So we want to line up this edge with this little line on the back that puts us on 18 megahertz, because when the dial's calibrated, there's a mark down here that you line it to. I'll do that just to show you. If we run the thing down the other end of the dial. This edge lines right up with that mark on the tape. Is that in? Yep, that's in frame. And it is recording. I gotta keep checking. So 18 megahertz, and I'm not hearing anything. And they want us to adjust C2B, the oscillator, which is the one closest to the front of the radio. There's my diddle stick, there it is. I'm not hearing it. Oh, ha ha ha. Of course I'm not hearing it. Shame on me. I'm on the wrong band. There we go. Now we should hear it. So this is what happens when I talk while I'm trying to do something. Maybe there's something wrong with that. Alright, I'm going to take that. I might have to replace that mica that's in there. I'm not going to keep scratching away at the camera here. I'm going to fix that. Well, this has been fun. I can't even get near it with the tuning tool. There's enough metal in the tip of that to throw it off. So I'm using a ceramic screwdriver. And on top of that, just the play in the screw threads, just putting pressure on the screw a little bit so that you're moving that tiny amount of play that's in the threads, throws the tuning off. If I push in on the screw and then release it, it comes back. So when you're tuning it, you can't apply pressure. You've got to let the screwdriver float in the head of the screw. It's that touchy. And even this thing's affecting the capacitance. Good enough. We're on 18. We're on 18. And it wants me to adjust this antenna trimmer, looking for a peak. You just keep rocking and tuning until you find a peak, but the tuning on this thing is so fussy. Oh, there's an improvement. This is the antenna trimmer, and what you do is just keep rocking the tuning while you're adjusting the antenna trimmer and try to find a peak, chase the peak until it's at its highest point, and I think that's about as good as I'm going to get it. It's kind of counterintuitive. You think you would peak the trimmer, but they want you to resonate between this capacitor and this one, so you just keep tuning back and forth until it hits its highest resonance point. Boy, I noticed earlier when I was playing with this, the shortwave tuning is so it just so fast. You got to keep going back and forth to get it to tune in. Not going to be a performer on shortwave, that's for sure. Not that these sets ever were, but most of them are a lot easier to tune than this one is. It sounds pretty good on the AM band, however, and it seems that this set must have seen a lot of use because I have that many tubes soft. They might have had this thing on all day when it was home. Okay, so then we want to go to 580 kilohertz and tune C13, which is the trimmer down there. So, yeah, 580. Turn off the modulation. .580 kilohertz. And tune this down here to 580. Turn on the modulation. 580. This trimmer cap down here. And I'm hearing nothing. Oh, there we go. I gotta remember, keep flipping the switch between AM and shortwave. Hell of a technician I am. Okay, 580. Then 1500 and C14, which is back here. Oh, duh. That's not the antenna trimmer. I'm not paying attention. I gotta go back and redo the 18 on this screw, is what they want. Alright. This is what happens when I'm trying to talk and think at the same time. The 286 won't keep up. So standard broadcast band, 1500 kilohertz. Turn off the modulation because the frequency counter won't deal with it. So I want band C, 1500. If there's modulation on the signal, the counter just goes off the rails. And see, right now it's reading 981. Harmonics everywhere. Wow. Right on the money. Yeah, exactly, 1500 kilohertz. Yeah, maybe just a smidge. No, that was it. On the money. Alright, I'm going to go back to the 18 megahertz. And switch bands. I remembered that time. Tune this up to 18. Turn off our modulation. Trying to get the front end of the counter to trigger on the fundamental is a real chore sometimes with these things. Alright, modulated RF. Now I'll rock the correct screw this time, I hope. There we go. Ugh, can't even turn it. Another scratchy one. You can't leave the deoxit in there because it changes the capacitance. That was a big jump right there. No, that one down. I think that's about as good as it's going to get. So we've got our 18 megahertz dialed in after cleaning up the trimmers. Get my cord out of here. Boy, nice and soft. You're nice and warm now. Okay. And a nice harmonic. They're everywhere. So, get the signal generator off of here. This is never going to be a nice Hallicrafter shortwave set. We'll turn the RF all the way down. Nobody's going to listen to shortwave on this thing. It's going to be only AM.
Guilty plea. There are tapes of Stephen Alford implicating a lot of very powerful people, and those tapes need to be made public because they. It's taken from us. Down to Nyquist. Trapezoid. Now as it is worked back and forth. Trapezoid looking for something out front.
There's just so much noise in this room.
That's hard to
Thank you, Murph. As the Wildcats get back to full strength, 5-on-5 with now 7 minutes and 50 seconds to go here in the second period. 1-0 BU here from the Whittemore Center in Durham. Played here by the Terriers.
And I guess that wraps it up, guys. We have installed our safety relay. We have our NTC in position, and you can almost keep your finger on that, but 60C is just a little too hot, but it's not incredibly hot. It's like trying to touch the vinyl seats on a sunny day after the car's been closed up. Not much hotter than that. That's perfectly acceptable temperature. I'll probably slip some Teflon sheathing over those leads. No, I'll wait till the other NTCs come in and see how they work out in here. But safety relay's in, NTC is in, our oddball transformer is absolutely fine. This thing's been on for hours and hours, and I still think most of the heat's coming from those tubes, because you stick your finger in here and holy cow does the back of your finger get hot. we'll have to wire up a length of antenna. Actually, when I put this back in the cabinet, when the cabinet's fixed, I'll probably put a binding post somewhere on the cabinet for the antenna so there isn't 30 feet of wire hanging out the back of it. And that way we can just put an antenna on it as necessary. It's not a bad sounding little radio. I was sitting here listening to it earlier on the phone when I was on the phone, and nice little set. Lousy shortwave receiver. Okay, the next project is going to be retubing this guy right here. We're going to convert this thing over so we can get rid of the resistors, both of them. This guy and the big honker that's up underneath here. We'll get rid of both of those, change this over to a pair of 35 volts on the rectifier and on the audio amp. The 4 other tubes will make 12 volts. That totals up to 120. The only thing we'll have to do, this is a different, this has 2 anodes in it. The tube that's going to replace it only has a single anode in it, so I'll have to rewire the power supply to accommodate that, and if necessary I'll add a little silicon diode if the voltage doesn't return back. This may handle it, I don't know, but the impedance is going to be twice what that tube is because this has got the 2 anodes tied together. We may have to add a diode and a resistor to bring the voltage back, but from that point on there'll be no resistors heating up the chassis. We'll be able to run it on 120 volts directly, and then we'll add an NTC for surge suppression when we turn it on, because we have some now. I forget what this radio drew. I might have to use the 300 milliamp ones when they come in instead of the 500 milliamp one. But we'll get this converted over. We'll make that in the next video, changing the tubes over and reworking the power supply. That's it for now. I'm the radio mechanic. I know that got a little boring at the end, but we had to get her up and going. Take care. We'll see you soon. Bye-bye.